Every All-Flo air-operated double diaphragm pump, or AODD pump, has a performance curve. Performance curves for each pump can be found within the pump's manual as well as on the pump's product page on our All-Flo website. All-Flo's AODD pump performance curves are made up of three axes: a horizontal axis, a vertical axis, and a curved axis. Let's dissect the elements of each one. Along the horizontal axis is the flow rate. Gallons per minute is identified at the bottom, while liters per minute is identified at the top. Along the vertical axis is the pressure. In an AODD pump, pressure can correspond to two things. It could correspond to the air inlet-outlet pressure in PSI and bar, identified on the left-hand side, or the total head in feet and meters of water identified in the right-hand side. The blue curved axis identifies the air inlet pressure. The red curved axis identifies energy consumption or air consumption of the AODD pump. All-Flo's AODD pump's air consumption is measured in standard cubic feet per minute. There are three main pieces of information an AODD pump performance curve can define. It can define the AODD pump's overall operating range, it can define the AODD pump's performance, and it can define the AODD pump's air consumption. The AODD pump's performance curve defines the pump's overall operating range. The operating range is the minimum to maximum gallons or liters pumped per minute. This is identified by quickly looking at the horizontal axis data range as well as considering the air inlet blue curved axis. For example, this performance curve is defining this AODD pump's overall operating range from a minimum of 0 gallons per minute to a maximum of over 150 gallons per minute. The AODD pump performance curve defines the pump's performance based on a specific operating point, utilizing the required gallons per minute at a certain feet of head. For example, a manufacturing plant requires an AODD pump to be able to perform at pumping 50 gallons per minute at 115 feet of head. To find out how well the AODD pump will perform, utilize the performance curve by finding the 50 gallons per minute along the horizontal axis, then follow the line up to the 115 feet of head along the vertical axis. The area where the horizontal axis and the vertical axis intersect is the operating point. From this operating point, the curve will identify the required air inlet pressure to achieve the desired performance by following the blue curved axis. In this example, the operating point is in between the 60 psi and 80 psi air inlet curves. Thus, the required air inlet pressure to operate the pump would be 70 psi. The AODD pump performance curve defines the pump's air consumption. Air consumption can be used to help size a compressor for your system as well as identify opportunities for cost savings. If we utilize the same operating point from the performance example, pumping 50 gallons per minute at 115 feet of head, how much air will the AODD pump consume? From this operating point, the performance curve identifies the AODD pump's air consumption by following the red curve axis. In this example, by following up the red curve axis, which lies between 40 and 60 SCFM, you can expect the AODD pump's air consumption to be about 48 SCFM. All-Flo's performance curves are developed from testing results of All-Flo AODD pumps pumping water. This is the best guide for pumping most fluids up to 2,150 centipoi. However, if the application requires the AODD pump to pump something much more viscous than 2,150 centipoise, a small calculation can be made to help read the performance curve. Refer to All-Flo's viscosity correction chart located within the guide section of the download library on All-Flo's website. As an example, Let's say a manufacturing company is pumping a product that has a viscosity of 7,500 centipoise at 50 psi. Utilizing the All-Flo viscosity correction chart, identify the viscosity correction factor. In this instance, the viscosity correction factor for 7,500 centipoise is 2.0. In order to obtain the same level of performance as water for the required flow rate of 15 gallons per minute, multiply the flow rate by the viscosity correction factor, in this case 2.0. The new required flow rate for a viscous product of 7,500 centipoise is 30 gallons per minute. Refer to the AODD pump performance curve once again and adjust the operating point to the viscosity correction flow rate of 30 gallons per minute. This allows you to reassess the new required air inlet pressure, which will be 60 psi, as well as the increase in air consumption, which will be 30 SCFM. Generally, whether pumping a liquid similar to water or something much more viscous, it is recommended to always operate an AODD pump in the middle part of its performance curve, rather than at the extreme conditions. This is the most efficient way to operate an AODD pump, not only from a performance and air consumption perspective, but it also helps extend the life of wear parts.